January 1991. Muskingum County, Ohio. A dragline excavator makes its final scoop. 22 stories tall, 27 million pounds. For 22 years, it ran 24 hours a day, 364 days a year, except on Christmas. It moved more earth than the Panama Canal, twice. The Central Ohio Coal Company shuts it down anyway, not because it broke, because the coal it uncovered, nobody wanted anymore. Bucyrus-Erie 4250W Big Muskie, the largest single-bucket digging machine ever built. Only one was ever made. It cost $25 million to build. They sold it for scrap at $700,000. This is what happens when the world changes and the machine does not. Early 1960s, American Electric Power needed more coal. Their Muskingum River power plant in Beverly, Ohio was expanding fast. 4 generating units and a 5th on the way. That 5th unit would increase output by 70%, and the coal had to come from somewhere close. The Meigs Creek No. 9 seam ran beneath 110,000 acres of hilly terrain in southeastern Ohio. Rich coal, high sulfur, buried under 185 feet of rock and soil. Getting to it meant removing everything on top. That material is called overburden. Removing it at the scale American Electric Power needed required something that did not exist yet. The company had 2 options: build 2 large drag lines at standard capacity or spend $25 million on one machine that could do the work of both. In 1966, they chose one machine. American Electric Power contracted the Bucyrus-Erie Company in South Milwaukee, Wisconsin, to build the largest walking drag line the world had ever seen. The model designation was 4250W. Nobody called it that. Everyone called it Big Muskie. The engineering was staggering. The machine stood 222 feet tall. Its boom stretched 330 feet. The bucket held 220 cubic yards, enough to fit 2 Greyhound buses side by side. Each scoop moved 325 tons of earth. The whole machine weighed 13,500 tons and moved on 4 hydraulic walking feet, creeping across the landscape at roughly 9 feet per hour. But Big Muskie could not be built in a factory and delivered. It was too large to transport in one piece, too large to transport in 10 pieces. Bucyrus-Erie fabricated the components in Wisconsin, then shipped everything to the mine site. 340 railcars, 260 trucks. It took over 200,000 man-hours to assemble on site. 2 full years of construction in the middle of Ohio coal country. On May 22, 1969, Big Muskie went to work. The power requirements were extraordinary. Big Muskie ran on electricity, not diesel. 13,800 volts were delivered through a trailing cable with its own dedicated transport vehicle. 28 electric motors, 18 at 1,000 horsepower each, 10 at 625 horsepower. Total output exceeded 50,000 horsepower. While operating, Big Muskie consumed the equivalent electricity of 27,500 homes. The power cost alone ran tens of thousands of dollars per hour. AEP negotiated special agreements with local Ohio utilities to handle the load. The crews worked around the clock, 4 rotating shifts of 7 people each. Each shift had an operator, an oiler, an electrician, a welder, 2 bulldozer operators, and 1 laborer. They stopped for 30-minute meal breaks, and for Christmas Day. That was it. Every other hour of every other day. For 22 years, Big Muskie moved earth. And move earth it did. By the time it shut down, Big Muskie had removed over 608 million cubic yards of overburden, uncovering more than 20 million tons of Ohio brown coal. The numbers sound abstract until you compare them. The construction of the original Panama Canal moved roughly 300 million cubic yards. Big Muskie doubled that. One machine, one location, one bucket at a time. Here is the thing about high-sulfur coal. It burns dirty. In 1977, the Clean Air Act changed the economics of everything Big Muskie uncovered. The act imposed strict limits on sulfur dioxide emissions from power plants. High-sulfur coal from Ohio and Appalachia suddenly became expensive to burn. Power companies had to install costly scrubbers or switched to low-sulfur coal from Wyoming's Powder River Basin. Western coal was cheaper to mine, cheaper to clean, easier to transport by rail, and increasingly what utilities wanted. Through the 1980s, demand for Ohio's high-sulfur coal dropped steadily. Electricity costs climbed. Public opposition to strip mining intensified. Big Muskie kept working, but the margins were collapsing around it. The machine that could move mountains was undermined by chemistry. The sulfur content of the coal it uncovered made it progressively less valuable in a market that now penalized dirty fuel. In January 1991, Central Ohio Coal Company removed Big Muskie from service. Not a mechanical failure, not a structural problem, an economic one. The coal wasn't worth the electricity it took to reach it. Then came the question nobody had planned for. What do you do with a 13,500-ton machine that can't be moved? AEP tried to sell it. No buyers. The cost of dismantling, transporting, and reassembling Big Muskie at another site ran into the millions. No domestic coal company still practicing open-pit mining at that scale wanted it. The few operations large enough were in Germany, where bucket wheel excavators had already made giant drag lines obsolete. Those German machines could move more overburden per day at lower power consumption. Big Muskie had no market, so it sat. For 8 years, the largest single bucket digging machine ever built stood motionless in the Ohio hills. Fans, enthusiasts, and historians campaigned to preserve it. Turn it into a museum. Make it a monument to American industrial ambition. The campaigns failed. Nobody could fund the maintenance, let alone a relocation. Then in 1999, the Environmental Protection Agency began enforcing the Surface Mining Control and Reclamation Act. The law required all equipment to be removed from former strip mines so the land could be remediated. Further delays meant millions in fines. American Electric Power had no choice. In January 1999, they awarded a scrapping contract to the Mayer Pollock Steel Corporation. The demolition crew used high explosives to sever the 5-inch cables holding Big Muskie's boom. The 330-foot boom crashed to the ground. Workers who had spent careers on the machine watched from a distance. One said he was sadder that day than when his dog died. An old farmer whose family land had been consumed by the mine decades earlier said something simpler. You hated to see it come, and you hated to see it go. The scrap was worth $700,000. It cost $25 million to build. Every component was recycled except one, the bucket. That 240-ton bucket was moved to Miners Memorial Park near McConnelsville, Ohio, where it sits today. Tourists stop and stand inside it. A high school marching band once fit inside for a photograph. Plaques explain what it was, what it did, and how much earth it moved. The land Big Muskie once stripped has been reclaimed. 10,000 acres became the Wilds, one of the largest wildlife conservation centers in North America. Giraffes, rhinoceros, and zebras now roam the same hills Big Muskie once carved open. A machine built to destroy a landscape created the conditions for one of the country's most unusual nature preserves. Big Muskie was not a failure of engineering. The machine did exactly what it was designed to do for over 2 decades. It was a failure of timing. It was built in an era when coal was king and electricity was cheap. It was retired in an era when clean air mattered more than cheap fuel. The Bucyrus-Erie 4250W proved that you could build the largest digging machine on Earth. What it could not prove was that the world would keep needing what it dug up. Big Muskie consumed the power of a small city to uncover coal that a changing economy no longer wanted. The machine did not become obsolete. Its purpose did. Now a relic sits in Ohio, open to the sky and surrounded by a wildlife park that exists because of what a machine tore apart and what nature slowly took back. That is the story of Big Muskie, the machine that moved more earth than the Panama Canal and ended up worth less than the scrap metal it was made of. If you're interested in the hidden economics behind machines that changed the world, subscribe. We're covering the stories nobody else tells. The equipment that worked, failed, or quietly reshaped entire industries. More coming soon.